Okay, continuing on with questions 4 and 5. Questions 6 and 7, I'm going to let you figure those ones out by yourself. They're pretty straightforward. But if you do have any questions, feel free to email me. Questions 4 and 5 are really important questions in physics, especially for the forces and dynamics, because if you understand these two questions, then you understand a lot of the guiding principles of this unit. So the first one is called Atwood's pulley. An Atwood's pulley involves a pulley, obviously, and then a mass over here, and a mass over here. And we're just going to make up some numbers for this. I'm going to say that this is 4 kilograms, and this is 9 kilograms. And obviously, since this one here is heavier, this one's going to accelerate down, this one's going to accelerate up. And intuitively, whatever the acceleration for the 9 going down is going to be for the 4 going up. They must be accelerating at the same rate, just in opposite directions. Now, is the 9 going to accelerate down at 9.81 meters per second squared? No, because the 4 is pulling the 9 actually upwards, isn't it? So the 9 is not going to accelerate at 9.81. If I took the 4 kilogram away, then it would. But this 4 kilogram is counterbalancing it, so it's kind of pulling the 9 in the opposite direction that gravity's pulling it. So here's how we deal with Atwood's pulley questions. We make a free-body diagram, and we're going to deal with the whole system in one. So the number that I'm going to put here is 13 kilograms, 4 kilograms, and 9 kilograms, 13. And what we're going to say for our free-body diagram, we're going to have everything along one line. So we're going to say that one force is pulling it this way, and one force is pulling it this way, and we're going to call this FG1 and FG2. And what are FG1 and FG2? Well, FG1 is right here, simply the force of gravity pulling the 9, this one down. FG2 is the force of gravity pulling this one down. But what you have to acknowledge is so gravity is pulling both of these down, but they're going in opposite directions in regards to the entire mass. The entire system is accelerating in one direction. This 9 is going down, and this one is going up. So they're going in opposite directions, and therefore this force of gravity, number 2 here, is going opposite to this force of gravity 1. And once you understand that concept, then you can just write a net force statement. The net force equals Fg1 plus Fg2, which equals the force of gravity 1 is going to be, the force of gravity pulling the 9 down is simply mg. So for this one, it's going to be the mass, 9, times the force of gravity, 9.81. And since this one is going down, I'm going to make that negative. Fg2, since this mass is accelerating up, 4, I'm going to make it positive. Even though we've said in previous lessons, gravity should always be negative if it's going down, but in this specific problem, we have to, there's an exception, because we have to acknowledge that these forces are in opposite directions. Therefore, one has to be negative and one has to be positive. Okay, so you stick those numbers into your calculator, and I've done it on the piece of paper here, and what you end up getting, I thought I did it on the piece of paper. Yes, I did. What you end up getting is a net force of 49.05 newtons. Okay, so that's the net force acting on the system. Now we can find the acceleration. So we'll call that equation number 1. Equation number 2, we're just going to use acceleration equals the net force divided by the mass. The net force we just calculated. And the mass in this case is the entire system. So you have to use 13 right there. And then you're going to divide those two numbers, and you end up getting an acceleration of 3.77 meters per second squared. So considerably smaller than the 9.81. So that is Atwood's pulley. The last one we're going to do on this lesson to help you with your assignment is called Fletcher's trolley, which is what you should have done when I was absent. So that's the lab you should have done. So Fletcher's trolley, similar principles to Atwood's pulley. in this case, we have a block attached to a string, goes over a pulley. We have a weight over here. I'm going to say that the block is 10 kilograms, and I'm going to say that the weight down here is 7 kilograms. And we're going to say that the force of friction on the block is 8.5 newtons. So there's my Fletcher's trolley problem for this one. And I'm going to deal with it much in the same way. I'm going to draw a free-body diagram. Free-body diagram. And what goes in here? What goes in the middle right here? 17, because that is the 10 plus the 7. It's the mass of the entire system. Whenever you're doing a net force statement, it must be the entire system. So what's going on in this one? Well, again, you may be confused because you can say, well, the block's going this way and the weight is going this way, so they're not going in along the same line. So how can you add them and subtract them? Well, you can, because really the weight, this weight here, what effect is it having? It's really pulling this 10 kilogram weight this way. So really, this force, in this direction is Fg. It is this one right here. And what force is pulling it this way? The force of friction. So there's our free body diagram for a Fletcher's trolley. You've got the force of gravity pulling it this way. Of course, we know that the force of gravity is actually pulling this weight down, this one here down. But in this case, it's causing the 10 kilogram mass to move to the right. So that's why we can draw the free body diagram that way. Now we can write a net force statement. The net force equals the force of friction plus the force of gravity. The force of friction, 8.5 newtons. And the force of gravity is going to be, the force of gravity over here is simply mg. In this case, 7 times negative 9.81. And again, we have to be careful. If this value here is positive, then this value here must be negative because they're going in opposite directions. All right, so you stick all that into your calculator and you should end up getting a net force of 60.17 newtons. And now we're similar solution to outwards pulley. Acceleration equals the net force divided by the mass. 60.17 divided by the mass of the entire system. The entire system, 17. Because obviously if you put just 7 in and just 10 in, you get totally different answers, wouldn't you? And there's no way they can be accelerating at different rates because they're both going to be accelerating at the same rate. Yes, the 10 is going to be accelerating this way, and the 7 is going to be accelerating there, but it will be the same magnitude. So divide those, and you end up getting, in this case, 3.54 meters per second squared. That is the acceleration of the system. That's the acceleration of the 7 going down and the 10 going across. Okay, I hope those solutions help you to figure out this assignment. Again, if you can do these 2 questions, then you're well on your way to understanding the basic principles of force and dynamics, and they're really important for Physics 30. So make sure you get a handle on this. All right, take care, and we'll be back with another lesson hopefully soon.